Can you find the total area of these two squares? If we let x be the side length of one of the squares, we can identify several chords of the semicircle whose lengths can be expressed in terms of x. But it isn't clear what the relationship is between the semicircle's radius and the lengths of these chords. Let's find what that relationship is. This is a circle with an arbitrary chord. Let r be the radius of the circle and theta be the angle subtending the chord. By drawing the altitude bisecting theta, we can see that half of the chord has length r sine theta over 2, which means that the length of the full chord is 2r sine theta over 2. This gives us a way to express the length of a chord in terms of the radius of its circle and its subtending angle. Looking back at the original problem, there are three chords whose lengths can be expressed both in terms of x and in terms of the radius and a subtending angle. From this one, we have that 2 times 5 sine theta 1 over 2 is equal to x. This chord coincides with the square's diagonal, which means that 2 times 5 sine theta 2 over 2 is equal to x times the square root of 2. The length of this last chord isn't immediately obvious, but a straightforward application of Pythagorean theorem shows that its length is x times the square root of 5. Using the equation from earlier, this means that 2 times 5 times the sine of theta 1 plus theta 2 over 2 is equal to x times the square root of 5. Now we have a system of 3 equations and 3 unknowns, and when it's solved, with some help from a computer, we find that x is equal to the square root of 10. And from there it's just a few straightforward calculations to reach the final answer, 20.